Welcome and welcome back to a new Unreal Engine video. Today we're tackling building and crafting, but first let me show you how I animated this armor. To do the animated equipment, I simply created a child class, added two scene components, on begin play, save those positions, then run a timeline between it with an external float curve between 0 and 2 with a height of 1, looping, and then do a lerp calculation, which will give us a start to end and an end to start position between those components. I will then run a function, do equipment animation, and this will be overwritten in the child class. In the child classes, we can take whatever component we want, set the relative location off of those variables we calculated. For rotation, we can simply take whatever component, break the rotator, add a constant, and reset it. Let's go ahead and create an actor with its own interface for our buildings. I'm going to create a custom object here with its own interface. I'm going to call this place worker. I'm going to go ahead and create another interface here called build user. This is going to go right on our character. Next, I'm just going to go ahead and create an item building data. This is going to hold the building class and place workers. Building is going to be singular. Place workers is going to be an array. In our equipment tags, let's go ahead and add a new effect for building activate. In our do equipment modification, let's modify our hooks to take in our gameplay tags. Let's go ahead and in the inventory component, create a notify building activated and a notifying building deactivated, both of them taking in the inventory slot. Let's go ahead and write a simple wrapper macro to check for that building activate tag. In the notify equip, let's add a sequence, check for the building activate tag, and then notify building activated. In the notify unequip, let's use that macro and then notify building deactivated. Let's go ahead on our inventory slot, add an accessor for our place workers. Implementation will look something like this. In the inventory component, let's go ahead and create a spawn place workers. That'll loop through those place workers, adding it to a local array, and then we'll return that local array. Let's go ahead and add two new functions to this inventory user. Notify building started takes an array of place workers. Notify building finished, nothing for now. Let's now go ahead and do the notify building activated by getting the place workers, spawning them, and sending them to the inventory user. The building deactivated will simply just notify building finished on the inventory user. Go ahead and add an initialize function on our place workers, taking in a build user. Implementation will just promote it to a variable. Let's go ahead and update our initialize function and take it an integer. Implementation now is just setting an index. On the place worker, let's go ahead and add two more functions, is valid, which returns a boolean, and invalidate, which does nothing. Let's go ahead and actually just remove this boolean from the is valid. We won't actually need it. Let's go ahead over in the build user interface, add a notify place workers valid. Let's place that boolean is valid along with an integer for an index. Let's go ahead and add our implementation in our place workers. Off this initialize, we'll set a timer with a refresh rate variable and promote the timer handle to a variable. The event will point to the is valid, which will run a validate place worker. If it's true, it will return notify place worker valid. The invalidate will just invalidate the timer handle. The validate place worker function is just simply a blank function we can override. Let's go ahead in our player character and add support for our place workers. We'll need three new variables: can build, active place workers, and place workers valid. On the building started, we'll go through and initialize our place workers. On the building finished, we'll go through and invalidate all of them. When we receive a valid notification from a place worker, we'll go through and check to see if all the place workers are valid, meaning that we can build. Go ahead and make this place worker an abstract class. Let's just go ahead and in the build user add a quick accessor for a line trace. Implementation is just a simple line trace. I went ahead and created a child class to just call that function, and it looks something like this. Let's go ahead in our item database now to update one of our items here to add the tag for building activate, and then we'll add that place worker. I'll add a print statement at the end of the notify just to see if we hit something. Let's go ahead and test it out now. Yep, we have line traces. Over in this place worker, after a few bits of testing, it turns out we'd never needed this branch and we should be updating it constantly. Let's go ahead and start begin refactoring a code. We're going to need a static mesh component, its own interface, and I moved the build user here. In our building component on the begin play, let's go ahead and get our owner as a build user and promote that to a variable. Let's go ahead in our building component, create three new functions: register place workers, invalidate all place workers, notify valid place workers, check. Let's go ahead and swap that variable for the building component in our place workers, swapping out the functions. The implementation for our interface methods is simply as easy as copy and pasting. Let's now go ahead and clean up these extra variables in the character. We do not need these. Let's go ahead and set up a simple accessor for our can build. Let's go ahead over in the build user and just remove this place worker valid. We don't need it anymore. In our character, our building started function now simply creates the component as a building component, promotes it to a variable. We register our place workers and attach it to our capsule. On the building finished, we simply invalidate all place workers. In our component, upon invalidation, we'll destroy the component. I'm going to go ahead and add two more functions to this inventory component: equip all and unequip all. Implementation simply runs the loop and either sets equipping or unequipping. Over in the build user interface, I simply removed the location from the end of this function, and now I'm returning the hit result. I had to just go ahead and fix up this function. Over in our building component, let's go ahead and add a function, get place position, and this will be the hit result and has hit. We're going to pass the values right on through. Implementation will just call the build user and pass the data through. In our child place worker, worker, I'm just going to simply swap out the functions with the new one. And I'm just going to fix up the initialize here for the parent call. Over in the place worker, let's go ahead and add a validation check for our building component because we can destroy the building component before the timer even triggers. Okay, let's jump in and test functionality. If I equip my armor, we can see we're doing a line trace and we're checking true and false. If I unequip my armor, we're now no longer doing a line trace. Let's now go ahead and create two materials, a red and green one. Now over in the building component, instead of printing the string off the true and false, we're going to reset the material and switch between green or red. I've added a test cube here for testing purposes. Let's go ahead and test functionality. Let's equip our armor. We see we have a green cube because our things are valid. Red cube, green cube, no cube. Woo! Over on the building component interface, let's go ahead and set up a set component location, taking in a new location. Implementation will simply just set the world location. Let's go ahead in our place worker and get our building components, get the place position, break the hit result, branch off that, either set the component location to either the location of the hit result or the location of the end of the trace and return either true or false. Okay, let's go ahead and test out functionality. Looks like it's working as expected if I add and remove the cube. Over in the inventory slot, let's set up an accessor for get all gameplay tags. Implementation will just return our pure function. Over in an inventory slot, let's go ahead and set up a simple accessor for a building class. Implementation is fairly simple. Let's go ahead over in our inventory component and set up a spawn building, taking a location and outputting a building. Implementation will just loop through the values, check to see if it's equipped, see if it's the activated one, get the class out of the inventory slot, spawn the actor, use it, set it as a local variable, and then break out of the loop. On the return node, we just simply return that local variable. Let's go ahead back over in our building component and simply cache the location. Let's go ahead now and add a simple accessor for that value of get component location, returning the location. Implementation looks simply like this. Over in our player character, to spawn the building, we have to just simply check, can we build off the component, get that location, and then pass it to our inventory component. One small bug fix on our spawn building, we need to notify that the building is finished. Now we have in the database a simple workbench. It's going to be a pickup base. It's going to have one stackable. It's going to use an equipment of workbench with at a grip point of R with the tag hand grip. It's going to activate our buildings. It's going to be a consumable of 1, and it's going to spawn the building workbench. And it's going to use the place worker of a line. Let's go ahead and test out functionality now. Let's go ahead and equip all of our items. We've got a workbench in a hand, and we've activated building mode. We're trying to build. We can only place it on the ground. If I press 4, we place it on the ground and stop building. Let's go ahead and update our inventory slot use consumable to return the current amount that we have. Now in the do consume, we can just simply pass through our current amount. In the inventory component, let's go ahead and update use consumable so we can check to see if we're still building. Let's go ahead and do a little test here. I'm going to swap out the building workbench for a simple cube. In the place worker folders, I'm going to create a simple place worker grid. Now instead of sending it directly to the location, we're going to use a grid size to do a grid calculation. The rudimentary grid calculation just simply relies on truncate to just make a vector. Over in our item database, I updated our simple workbench to use the place worker grid. Let's go ahead now and give it a test and see what it looks like. That looks like a grid to me. Let's go ahead and add the ability to switch between states here. We're going to add a new table tag and add no work, line, and grid. In our building component, let's go ahead and add a new gameplay tag, active build state, and set this to rep notify. On rep notify, we're going to check to see if the active tag is no work. If it's no work, we're going to invalidate all place workers. Over in the building component interface, let's add two new functions, check active tag and set active tag. Implementation for set active tag will look like this. Implementation for check active tag will look like this. In the parent, let's go ahead and set up a gameplay tag for place worker tag. Over in the parent place worker, on the validate place worker, we're going to check the tag and return the value. In our children place worker, we can now add a place worker tag and check to see if we should run the calculation. Over in our item database, let's go ahead and set up both our place workers. Now on the character, we can simply set up key presses and set the tags. Let's go ahead and test functionality. We can see we're not placing. Let's go ahead and hit 5. We are now in smooth place. If I hit 6, we are now in grid place. Over in the player character, where we calculate the line trace, let's go ahead and promote the distance value to a variable. Go ahead and set up some simple key presses here to modify that line trace, and the place workers will take care of the rest. Let's go ahead and validate functionality. We've got our cube, we are placing, and we can place closer together, and we can place farther back. Very good. Let's move on to crafting. Let's now go ahead and create a new object with its own interface called recipe worker. Let's go ahead here now and create a custom database for our recipes. The recipe data structure currently just holds the recipe worker class. Let's go ahead and create a new structure here, item recipe data. It's going to hold our received amount and item cost with item IDs and the amount along with the work amount. Recipe data added to our item. Let's go ahead and add initialize function to our recipe worker. It's going to take in a crafting component, item ID, cost, and work amount. Implementation in the recipe worker is just simply setting the variables. In the recipe worker interface, let's add a start recipe, a do recipe, and an is recipe finished. Implementation for start recipe is simply going to set a timer looping on 1 second. That's going to do a recipe work decrementing work amount. If it's less than or equal to 0, it will invalidate the timer. Is recipe finished is simply just going to check the work amount and return the work amount. Now we've got at least a rough idea of what the recipe workers are. Let's go ahead and move on to the crafting component. Let's go ahead in the crafting component interface and add 3 new functions: add recipes, notify recipe started, and notify recipe finished. Over in the crafting component, let's go ahead and set up 2 new variables: inventory user and active recipes. Implementation for the begin play to set the inventory user event. All recipes will simply loop through each of the recipes and start the recipe and add it to the map. Let's go ahead and create an all recipes finished. It's going to loop through all the active recipes, check to see if they're finished. If they're all finished, it's going to destroy the component. Let's go ahead and over in the recipe worker and let's take advantage of the notify recipe started and the notify recipe finished. Let's go ahead and on a recipe worker add a simple accessor to get the item and the cost. Implementation will simply just return the item and cost. Let's go ahead and in the inventory user interface add a notify user recipe finished, taking in a recipe. Now implementation in our crafting component is simply just going to pass it to the inventory user. Let's now just go do the same thing for started. The implementation for started and finished now looks like this. In our inventory component interface, let's go ahead and add a notify inventory recipe started and a notify inventory recipe finished, both taking in a recipe. Implementation will just simply pass it to the inventory component. In the inventory component, on the inventory recipe finished, we're going to go through the cost and we're going to subtract it from the inventory. And then we're going to spawn our item. Let's go ahead and create a new structure called recipe linker. This is going to take in a recipe ID with a recipe database. Now let's just go ahead and add that to the item recipe data. Let's go ahead over in the recipe worker interface and just move the crafting component out of the initialize and into the start recipe. With the interface updated, the implementation now looks like this. We simply set the crafting component on start. Now over in the crafting component, we simply just pass in self when we start the recipe. Now we can implement spawn recipe by simply querying the database, grabbing the recipe, spawning the recipe as a recipe worker, initializing it with all the data from the database, and then returning that recipe. Over in the inventory user interface, let's now add a notify user recipe received, taking in a recipe. Let's go ahead and in our inventory component interface, add a validate inventory amount. It's going to take in a recipe and simply return has amount. Turns out over on the inventory side, I didn't have an accessor for get current amount, so let's go ahead and add one. Implementation is simply returning current amount. Let's go ahead and do the same thing for get item ID. Implementation, let's go ahead and implement the validate inventory in our inventory component. It's going to simply loop over the cost of the recipe, check our inventory. If we have enough, we will say we have enough. If we don't, we're going to pass just not valid. Let's just go ahead and over in the inventory component and do a little bit of refactoring. It was a mistake to pass in the recipe. Let's just go ahead and pass in the recipe cost instead. Let's go ahead and also modify the spawn recipe to add a boolean to check to see if our recipe we're outputting is valid. Implementation for the validate inventory amount simply just passes the variable into the keys now. Let's go ahead and just update the spawn recipe to use the validate inventory amount. Off a branch, we'll set it to false. Off a true, it'll be true. Over in our inventory slot, let's update is slot valid to take into consideration for the 0 value, returning not valid off a 0, and then checking the amount. If it's positive, we do the same check as before. If it's negative, we just simply check to see if it's above 1. Over in the apply slot modification now, let's take into account for negatives. We're going to add a simple branch. If it's false, meaning it's negative, we're going to go up. We're going to calculate the sum. We're going to check to see if it's less than 0. If it's less than 0, we're going to invalidate the slot and send back the total. If it's above 0, we're just going to simply set the current amount. Now let's go ahead and implement our notify user recipe received. When we take in an item ID, we're going to check to see if we can spawn the recipe. If we spawn the recipe, we're going to spawn the component. We're going to add the recipes and then attach that component. Let's go ahead and test functionality, pick up some items, and start crafting. After 3 seconds, we should start crafting. Let's see what happens. Oh no, we're playing more than one. We should no. To resolve that error, I had to call the all recipes finished at the end of the notify recipe finished. I also had to fix the all recipes finished because it was not invalidating correctly. In the inventory slot, I completely forgot that we had to check the item ID when we're subtracting. Now over in the recipe, we have a recipe workbench with a recipe class of BP recipe worker. In our item database, we now have a recipe cost of an item basic, an item metal hat. It'll take 3 of each and it'll output 1. It'll take 3 seconds to do. It'll take that recipe workbench, and it'll take it from that recipe database. I've got 2 items here. There's an item basic of 10 and an item basic metal hat of 10 as well. Let's go ahead and test out basic functionality. I should be able to pick up my items. Let's see, we have them in our inventory. And after 3 seconds, the crafting should finish, and we should have a simple workbench. Let's see, we have a simple workbench in hand, and we can start building, and we can place it. Perfect. Alright guys, that'll finish it up for today's video. I hope you guys enjoyed, and I hope you learned a lot. I'll see you in the next one.